T. Clark here, and this video is going to go over the AP Computer Science A FRQ number 4B for 2024. And in 4B, we're continuing our grid path class that they give us way back in the first page, where we still are using the grid, and we're going to have locations as well. Let's see what we have to do. So we have to write the sum path method, which returns the sum of all values on the path in the grid. So the path, so what's a path? That's a question. Path begins with the element that at row and column and is determined by successive calls to get next lock. Okay, and then so we have to use that call that method, excuse me, and then the path ends when you're in the last row and last column, so the bottom right spot. So for example, if we started at 1, 1, we start right here at 3, and then we find the smallest one, the minimum one between the bottom and right. Remember the bottom and right, but that get next location does that for us. We don't have to worry about it. It'll just say this is the next one, this is the next one, and this is the next one. And then when we're here, we're done. So either way, once we get to one spot, we want to add that to the sum. So I'm going to start by saying int result as usual, but instead of starting at 0, I'm going to say int result is that first spot, grid row column, because it tells me in the preconditions that row is a valid row and column is a valid call. Yeah. What else does it say as a precondition for some path? They do not specify the element in the last row and last column of grid. Okay. Okay. I don't think I have to worry about that. So I get the first item, and then I need to get to the next spot. So I'm going to say as long as while I'm not at the last spot. So as long as I'm not in this row or this last row, last rightmost column, I'm going to keep going. So as long as I'm not in the bottom, so row is the length minus 1, and I'm not, and column is grid bracket 0 dot length minus 1. So as long as I'm not at the last spot, so this would be the last spot, and while I'm not there, I'm going to get the next row and column. So I'm just going to say, okay, I need a location. I'll call it next equals get next lock. I think that's what it's called. I can check right here. Get next lock. I need a row and column. So get the next location from the row and column where I'm at right now, the position I'm at right now. It'll give me the next location. And then what I have to do is I have to, I'm at the next one now. So let's say I'm at the next one. I need to update where I'm at. So I'm going to say my new row is going to be at the next one. And then now I have to use that accessor method. So I need to get the next row, the row from the next one. So the row. I'm going to triple check, go back up, flip the pages. Excuse me. And then that's my accessor method is get row. But no, not the row, it's get row. Oh, I must have messed up. Oh, how did I not notice a get row? Get row. I was looking at the wrong thing, so I'm going to go back down and I'm going to look at the right thing now. So I'm going to look down here and say, okay, get column. There we go. That's what I was looking for. Get row and get column. So column is the next locations get column. So that's my new position, the next position, and then I'm going to add to it. So I'm going to add to the result the number at that grid that I just landed on. So whenever I land on the next one, on a new one, either at the first one or any subsequent one, next one, I'm going to immediately add that that number there. And then at the very end, don't forget, return result. Let's make sure I don't have any code down there. Okay, so that should be it. Let me run it and make sure. Okay, I don't need this sidebar. Okay, it says correct 19 and 19. Okay, it should be 19 and it's 19. I'm going to change it a little bit. I'm going to change my main. I'm going to change it so that the bottom number is a 1. So instead of 33, it's going to go down and then over. So I'm going to go to the bottom row. And so instead of 33, I think I was messing around with it, and it's a 31. It has to be 31 if it goes that path. And then it still works. Okay, let's see. 3 plus 2 plus 1 plus 18 plus 6 plus 1. Yeah, that's 31. I read that a lot of people were doing the this way. Wait. So some path you could do it recursively as well. So I'm going to redo this. Actually, I'm going to yeah, I'll delete it. I'm going to redo it with a recursive solution. The recursive solution is very, very elegant. So I say if I'm at the last position. So if the row is at the bottom and the column is all the way to the right, grid bracket 0 dot length. So if I'm at this spot right here, this bottom right, so bottom is length minus 1, rightmost is bracket 0 dot length minus 1. So if that's true, this is my base case, I'm just going to return that row, the number at that row and column. So whatever grid number is there, that's what the sum is. And then the I'm going to get the next location. Next, not an equal, next equals get next lock row column. So again, I still have to get that next location no matter what. Get next lock. I'm going to double check I spelled it correctly. Get next lock row column. Okay, looks good. And then I'm going to say I'm going to return. My sum is going to be wherever I'm at. So row and column plus the sum of the path of everything else. So if I'm right here, if I'm at 3, I'm going to say, okay, get the sum of where I'm at plus everything else in the path. So everything else in the path would be the sum of path. So there's my recursive call. I'm calling the same thing. And then in here, I'm going to put that next dot get row. There we go. I got it right this time. And then next dot get call. So again, the recursive call says get where you're at, the 3, plus the sum of everything after it, or sum of everything in the next path. And then the next time I go through, it wouldn't be at the end, I'll be at the 2 now. And then I'd say, okay, get the next one, which is the 9 spot. And I'd say, okay, get the position number here, 2, plus everything in the remaining path. So then that should work out. And I think it does. If it worked out, 31, 31, I'm going to go back to my main. It's kind of hard in this. I'm using GitHub right now. It's kind of weird. I'm going to change it back to the original numbers and just make sure I get the right answer with the original numbers using my my main stuff I hacked together earlier. So it looks like I got it 19. So this is a recursive way you could have solved the sum path. Either way would have worked. It should have worked. I think I got one point wrong when I was doing it originally on my paper because I had my original while loop kind of weird. But either way, hopefully you got this point. Have a good day.